Today, we are on 1-9 in Precalculus complex numbers from magnitude and direction. You know what those things mean, hopefully from yesterday. Today's date is Thursday, September 19th, 2019, 91919. All right, so, someone, read the objective. Quiet raise hand. Eva, go.
Convert magnitude and direction to rectangular form. I don't have any.
I never handed out the cards. Tisk, Mr. Sindel. No, I'm going to print out another one for you. I printed it out, actually. It just needs to be cut up and laminated. James, do you want to hand out the cards real quick? Am I losing them more and more each day? Is someone just like randomly taking them? All right, so Eva, thank you for the 50 XP. Andrea, you got her? I need to revamp the XP because it's too hard for game wardens to find. I will make it better. That was for me, not for the game wardens. All right, so yeah, so we had magnitude and direction yesterday, but now we're kind of going backwards. So today, if you know how to go forwards, then you should know how to go backwards in theory, but it's kind of hard to do. So I will show you how to do it. So, but from yesterday, say I have a complex number, a plus bi. Thank you. Say I have a plus bi. How do I find the absolute value or the magnitude of that? Just look at your notes. Go back to your notes. You have the formula. Stego.
This is just a guess. Is it a minus bi?
That is the conjugate, which is not quite right. That's with a bar over it. I guess there's bars on the sides, bars on the top. It's kind of confusing. Bars on the side means absolute value or the magnitude. So how do I find that? Something with a square root. Look back at your notes. I'm giving the answer to someone that has a card. Raise your hand with a card. Sorry, Eva. I've got to get these other people online. Look back at your notes. Notes from yesterday. If I'm taking the absolute value, what is the formula? You're using the Pythagorean theorem from yesterday.
B squared plus A squared.
B squared plus A squared. And then I do what to it? Chris? I do that to it, Chris? All right, thank you, Chris. I'll give you the 50 XP. Yeah, so that's in our notes. It could have been A squared plus B squared. It doesn't matter the order there. What about theta? I had to use an arc function. Was it arc sine? Was there quiet raise hand out there? Quiet raise hand. Please, quiet raise hand. Andrea? Arctangent. So arctangent of what? Imaginary over real. B over A. There it is. So those are the two formulas that you should have memorized. They are going to be used on the quiz, next quiz, and the next upcoming test. Test is upon us. It's close. Let's get some vocab. Thank you. Okay, so first of all, what does rectangular form mean? What form? We've been dealing with this form over and over. Something plus something. I have it written down in the review section. It is there. Is there a quiet raise hand that can just repeat that? Oh yeah, card, Stego. Ooh, careful. This is rectangular form right here. A plus bi. Everyone write it down. That is rectangular form. So when I say the word rectangular form, now you know what I'm talking about. I'm just talking about A plus bi. He's trying to kill me. He's trying to get his revenge for assigned seating. This is really good for adding and subtracting complex numbers. Adding and subtracting. Unfortunately, it's not very good for multiplying. If I had to do, for example, don't write this down, but if I wanted to do 1 plus 2i to the power of 7, you probably don't know what that is. Question, go for it.
How do fish sleep?
That's a good question. I don't know, but it's not related to the math lesson, so if I remember it, or if you remember it and remind me after the lesson, we will totally look that up. But for example, 1 to the power of 2i to the power of 7, that is really, really hard to do. And we'll have to learn another form to get there. But for now, we're really good at adding and subtracting in this a plus bi form. If I add them, I literally add the real, add the imaginary. So far, so good. Nod your heads. You're awake. Only half of us are awake. Okay, I'll try. I know that today's a hard day with what's happening. Modulus. This is our new word. This is the official word. I will be using this word over and over again. This is another word for, it's one of these things up here. One of these things up here. Take a guess, Eva. A good guess. It's going to be absolute what? absolute
Value.
value, which is the same thing as magnitude. Yeah, there it is. And Andrea, it's your call as to who to give the XP to. All right, so modulus. There's 3 words now that are all the same word. Modulus is the same thing as absolute value, which is the same thing as magnitude. I can use them interchangeably. The most formal that I can say is modulus. So if I came back up here, I could have said the modulus of a plus bi, or the absolute value of a plus bi, or the magnitude of a plus bi. All of that is the same formula. I'm talking about the same 3 words. We're okay. Let's talk about our other official word, the argument. This is another word for quiet raised hand. Quiet raised hand. Who can get this one? What's the other half? If we have the absolute value or the modulus or the magnitude, what is the other thing that we always talk about? We just talked about it yesterday. We talked about it already today. It's that theta. Give me the word for it. Can I please get more people?
Velocity.
Quiet raised hand, Chris. Come on, Chris. Eva, go for it again.
Direction.
It is indeed direction. So a modulus and argument. Those are the 2 things that we need. All right, so I built this thing for us right here. It has a modulus and argument. So we're going to start with a modulus and argument now. So pick an argument. I'm going to randomly drag this around. 225. Okay, that's my argument. My argument is 225, and then my modulus, I will change the length to some length, and this will grow. Everyone good on what's going to happen? So again, if I come back here, usually you start with a modulus of 1, because 1 times anything is that anything. So this basically doesn't have a modulus yet, and I can choose whatever angle I want. Let's choose this time 150, and then I can have a modulus of 5. I come out there. I can come out to some some complex number this other way. Eventually I'll teach you about this, I think, tomorrow. It's called polar form. But I have an argument and a modulus. Can everyone visualize what's happening now? Nod our heads, nod our heads. We can see what's happening. So what I want to do now is go backwards. So if I have an argument of 45 degrees and I have a modulus of 4, I want to find the rectangular form. That is our objective. I need to convert magnitude and direction, or modulus and argument, to rectangular form. I need to go back to a plus bi. What is that? Well, it looks like 2.8, but it has to be exact. I need to know exactly the real dimension, the exact imaginary direction or dimension. How do I find that? That's our giant question for today. Does anyone have any ideas? I'll give you a hint. You use trigonometry. And what do we need in order to even use trigonometry? Something basic. A triangle, a right triangle. So let's go ahead and make it, Sego. Sego, where do we make it? Yeah, so go straight down from this point. In fact, I have technology, so I could use a straight line. You could just sketch a line real quick, though. So yeah, make a line straight down here, and then this line that comes out from the origin. It is actually still called the origin. I think in my yesterday's notes I said that that's not called the origin. It's still called the origin. It's the origin of the complex plane. So I made my right triangle. We'll make that little right triangle symbol. There is my right triangle, which means I can use trigonometry. All right, you guys get to choose. It doesn't matter one way or the other. Should we find the imaginary direction first or the real direction first? Just someone shout it out.
Real.
Real. Let's do the real. Okay, so let's say that this real, let's call it, I don't know, R for real. I don't care. Some letter, R. So, using SOHCAHTOA, what trig function are we going to be using if I have 4 and R? Those are the 2 things that I have, 4 and R. And this is my angle of reference, 45 degrees, with a quiet raised hand. Which trig function am I going to be using for these 2 sides? Only one person knows. You can check the notes from yesterday. We did a review of trig. Stego? Cosine. Why cosine? Perfect. Well said. This is the adjacent. Adjacent literally means next to. It is adjacent. If you have an adjacent neighbor, it's your next to neighbor. This is the leg that is next to 45 degrees, so it's the adjacent. And then, of course, I have the hypotenuse, HYP. And A over H, that is SOHCAHTOA. So it's the C. It is indeed cosine. So let's set it up. I will help you do this. It's going to be cosine of our argument, cosine of 45 degrees. And then Stego, can you do the rest to get that final 50 XP that Andre already gave you? It's going to be cosine of 45 is equal to what over what? So R over 4. Everyone write it down. Perfect. We have set up our trig function. Now we need to solve for r. So what are we going to do to both sides with a quiet raised hand? This is easy. This is algebra 1. R is now being divided by 4. Inverse operation of divided by. How do I solve for r? Easy XP here. I want to get more people with cards. I'm trying to give you a freebie here. Freebie. Inverse operation of divide. Come on, anyone. Okay, Andrea. Multiply both sides by 4. There it is. So multiply the left-hand side and the right-hand side by 4. And we get our new equation, which says that r is equal to 4 cosine of 45. Let's try it again with, we'll call it I. I don't like calling it I. Let's call it M for imaginary. It's the second letter. It works. Let's call that M. I need to find M. Let's go through the whole process again. And the quick way of doing it too is you can just hit the plus next to it. So how do I find M? I'm using 4 and M. So which trig function am I going to be using? Quiet raised hand here. Hypotenuse, and that's not the adjacent. The other one is the cross. Which trig function? Stego got it last time, so I'm going to call in someone aside from Stego because she knows her trig. Give Eva another shot.
Sine.
It is indeed sine. Can you set it up for us?
Sine of 45 is equal to m over 4.
This is m divided by 4. All right, and we'll just get through this. I'm going to multiply everything by 4, and I get, I'll do this in green here, 4 sine of 45 is equal to m for imaginary. All right, but now let's pretend, what if I didn't give you 45 degrees? What if this was theta? What if this, instead of 4, what if it was absolute value of z? So all we have to do now is trade out the 4 for absolute value of z, the 45 for theta, and we have our formula. So coming down here, I just need to plug in the real dimension. The real dimension was this one. Change out the 4 for absolute value of z, and change out the 45 for theta. Can someone tell me what the formula is? The formula to find rectangular form. Stego.
Is that 4 plus 45i?
So the 4 is being substituted out. You have to use these letters right here. Absolute value of z and theta. So instead of 4, it's going to be, the absolute value of z. Absolute value of z times what? Times cosine, good, of 45 turned into one of these two letters? Theta. Perfect. And then I have to do the imaginary one. Who can tell me which one that is? The formula. Quiet raised hand. You're basically just copying what Stego did, but you're switching the trig function. Gio, you think you can do it? Chris, you want to give it a shot? Eva, poke him as he awake. James, you want to give it a shot? Just change the trig function. Repeat the exact same thing. You got this, James. Help me out here, man. Teflon. All right, Eva.
Absolute value of z times theta.
Sine of theta, there it is. That is our formula. That is the thing that you need to memorize. So we have 3 formulas now. 1, 2, and this is our third one, 3. We have 3 formulas. If you just use this formula, you don't even have to do anything special like, oh, I need to add 180 degrees. No, it's a formula, done. And then there is one extra special thing, I guess, which is this, special right triangles. We're going to be adding that on top of it. But before we do that, let's do example 1 where it's just a simple plug and chug question. I know that it's a plug and chug question because it says round to the nearest thousandth. So I plug it into the calculator spits it out. But if it said alternatively, down here in example number 2, express your answer in exact terms, that means you have to use a square root somewhere in your answer. Well, unless it's a nice number like 1, which is not, you don't need a square root, or 2. So this one, just a plug and chug. I'll show you the quickest way to do this. So if you don't do this now, but if you go over to your calculator, and I'm just going to create some random variables. I'm going to say that A is going to be, or let's say, what is it going to be? I'm going to say M for modulus is equal to, so M times cosine of my argument. So I can just make this theta, and I'll just hit enter. You'll be very confused right now, and let me zoom in so you guys can actually see. And I'm going to do M times sine of theta. Nothing happens. But if I now all of a sudden say M is equal to, what is it for this one? What is M equal to in this one? What is the modulus? Shout it out. You only have 2 numbers.
7.
Modulus is 7 because absolute value is modulus. So I'm going to say M is equal to 7, and I'm going to say theta is equal to 150. Theta equals 150, and bada boom, bada bing, it has our answer. M cosine is this, M sine is this. You don't have to worry about radians or degrees. It's always going to be degrees for this lesson. So sine is the imaginary direction, cosine is the real dimension, and this is the same thing for physics. How many of you are in physics right now? All of you. So I don't know if you've learned this already, but maybe Mr. Brown will be impressed. If you're going in the x direction, left and right, it's always going to be cosine. If you're going up and down, it's always going to be sine. So when you need to turn your velocity into component form where you just have up and down and left and right, when you separate velocity of a cannonball or whatever you're doing, cosine is going to be the left and right. That's the one that has a constant speed, whereas sine, up and down, is affected by gravity. That's the one that you're going to use for sine. Sine is up and down, cosine left and right. Well, hopefully you'll be ready for that, but we'll see. So I come back here and I have my answer. So left and right is negative 6.06. We're rounding to the nearest thousandth, so to this decimal to 6. So negative 6.06, write it down. Negative 6.06 plus the imaginary, and the imaginary is the sine, so that's going to be 3.5i plus 0.5. Say again? This is the tenths place right here. The hundredths is the 6, so I guess 3.50 if you wanted the hundredths place. I. And there's your answer. It's literally plugging in to the calculator. Like that. And if you want to just do it over and over again, I'm using this so I can change this to 160, and it changes all my numbers.
So for the homework, are they going to need to use Desmos?
Yes, Desmos calculator. It will say on the homework, use a calculator. All right, so now we have to make things harder with special right triangles. We're on the back. All right, we went over the warm-up briefly. We only got to 2s or 3s on our understanding of special right triangles. I know it is review from geometry, which is a review of Algebra 2. But a 45, 45, 90 triangle, let's assume that this is x. Let's assume that one over here is going to be x. If this is x, what are the other sides? Is there a quiet raised hand that can tell me what the other dimensions are of a 45, 45, 90 triangle? Eva, go for it.
X squared with 2 on the x.
There it is. Thank you, Eva. Is there another volunteer that can tell me the dimensions of a 30, 60, 90 triangle? Again, this was on your warm-up. Stego?
This is a guess. Is the hypotenuse x squared of 3?
Ooh, x squared of 3 is smaller, so it should be down here. X squared of 3, and then therefore the hypotenuse is, there it is, 2x. So you need to have these triangles memorized for tonight. It is there in your notes if you copied it down correctly. And our final example, the hard one, it's the same problem. Notice it's a copy-paste, but I just changed the last line. It was 7 and 150, 7 and 150. This one has the added hardness of saying that it is in exact terms. Well, cool thing for you guys is that if I come back here and change this to 150, 3.5, that is exact. So it is going to be plus 3.5i. So we're going to go something plus 3.5i. The difficult part is getting this negative 6.06 into an exact form. Everything that says get it in exact terms will give you some sort of special right triangle. The way that you're going to find this is by actually making a little sketch. So here's my sketch. So make your complex plane. There it is. I'm going to say 150 degrees. Well, I know that right here would be 90 degrees if it's straight up. 150 degrees is 60 more than 90, or I can think of it as it's 180, which is over here, minus 30, so right about there. So make about 30 degrees right there. And there's your special right triangle. It's a, and I'm going to redraw that triangle after I make my graph, but my special right triangle looks like this, where I have 30 down here, 60 up here, a right angle here, and hey, look, I have a triangle that helps me out right there. So I know that the modulus was what? The hypotenuse was what? Shout it out. Hypotenuse was the modulus, which is 7. Okay, and I'm trying to find the imaginary, or am I trying to find the real? The real. The imaginary right here is 3.5. We already figured that out. In fact, we can use that in our answer to help us. But we're trying to find this real. We'll call it x for now, I guess. So let's pretend that we don't know 3.5 and we're just dealing with x. Which trig function would I be using? Shout it out if you know it. Is it sine or cosine? So we're going to be using, I guess you could, it depends on which angle you want to use, right? If you want to use 60, you could use sine. If you want to use 30, you could use cosine. So let's go ahead and say, let's use 30. If I'm using 30, that interior angle, usually use the one that's always closest to the origin. Then I'm using 30, so I'm going to be using cosine. Let's set up our problem. We say that cosine, oh wait, we don't even need to use cosine. What am I saying? It's a special right triangle, Mr. Sindel. You don't even need to use sine or cosine. Oh my gosh. I'm sorry, guys. If I have the hypotenuse, to get from here to here, I did what? Divide by 2. What's 7 divided by 2? 3.5. We had 3.5. Now to get from x over to x squared to 3, what is the operation? You multiply by, multiply by square root of 3. So multiply by square root of 3. So take whatever the short leg is, multiply by square root of 3, and you will get the long leg. So the short leg was, so the long leg therefore is 3.5 square root of 3. There it is. 3.5 square root of 3. I can make that bigger because I have more room. 3.5 square root of 3 plus 3.55. And you can even check that on the calculator too. So I'm going to alt tab real quick, I'll come back. But if I come down here and I do, what is 3.5 times the square root of 3? 6.06. There it is. Oh, but there is a problem with that, isn't there? We were going left, so it should be a negative. Because we were over here on the left-hand side, the negative real direction. So just be careful of that. Do we all see the difference between negative 6 versus positive 6? If we made this a negative, just by putting negative there, then we'd get the exact same number up here. This is exact, this was rounded. Exact has a square root, rounded has a decimal. That we have to round. All right, and that's it for the notes.
So what's your answer for that? Is it just the negative 3.5? That's your answer for exact terms?
That's the answer for exact terms. Because exact terms, when I see the exact, that means use a square root, which means use a special right triangle. Which is kind of nice in one way because you don't have to use any trig, but on the other way you have to remember special right triangles.